All right. So when 5 is added to 3 more than a certain number, the result is 19. Okay, what is the number? I would say, what did you guys do for this? So we got an idea? Yes, Elizabeth?
I think 5x plus x plus 3.
Okay, I think so too. Okay, so I'm thinking something like, I would say, let x represent the number. Okay, and then create a bunch of situations here, right? So you're going to say, okay, 5 is added to 3 more. The result is 19. Is this what you were saying, Elizabeth? All right. And so we can get 5 plus 3 is going to be 8 plus x is equal to 19. And then just solve for x. Okay, so we're going to subtract 8 from both sides. X is going to be 19, take away 8. X will equal 11. Is that what you got, Elizabeth? All right, did we get the right answer? Let's check. What number is this? Number 1. All right, we're good. Okay. So then you would say, therefore, this will hopefully, like this process today, as long as you buy into it, you'll understand maybe why we're writing the therefore statement today, okay? The number is 11, all right? I agree that's a little tedious for the context of this particular question. Yes, Ollie, okay?
What are the 3 dots in front of it?
Oh, 3 dots means therefore. Sorry, that's a valid question. I never really talked about that. Just took that for granted. Okay. Alrighty. What else did we want to see? Want to see number?
We have 1, 3, 6, and 9.
All right, let's take a look. I'm gonna try 9 and see if I can get it. You guys see what you think. Okay. Okay. I'm gonna say here's how I would tackle this question. Okay, the sum of 3 integers is 108. What are the 3 integers? Okay. I'm going to say let x represent the first integer. Okay, everybody happy with that? Then I'm going to say, okay, what's the next integer? Let x plus 1 represent the next integer. Oh, integer doesn't have an R in it. My bad. I thought that was kind of funny. Integer. Is everybody happy with that? Everyone know what I'm saying? So if I just randomly pick a number like 20, then obviously the next number is going to be 20 plus 1, which is 21. Okay? Is everybody all right with that? And then obviously if it's 3 consecutive integers, then we're going to say let x plus 2 represent the third integer. Is everybody happy with that? So then it tells you that all 3 of these have to add to 108. So we know if we're adding, then we're just going to go plus and plus. So I'm just going to say, okay, x plus 1 plus x plus 2 equals 108. Does anybody have any questions? Comments? Concerns? Am I doing okay, Greer?
Wouldn't it be -1? X plus 1 plus x minus 1?
No, because they want you to find the result for the actual number.
Oh, we can do that after. I'll do that after. My goal right now is to find what x is, and then I can go back to my let statements to find out what the actual numbers are. Does that make sense? Sorry, that's a good question. There are a couple different ways to do this depending on which road you decide to go down when, okay? What I'm gonna do is I'm gonna solve for x. Once I have a result for x, I can go back to my let statements. That's why this is kind of important, right? So I can go back to that and just substitute x in and solve for, like there's no question there. Once I have x, then x plus 1 is we could even say not the next, we could say the second, right? Your let statements, that's why they're so important. They're like, they tell you exactly what's there. And so once you solve for x, you can go back to the let statements and plug in what x is equal to, and you'll get your answers, okay? Instead of having to do this x minus funny business, okay? It's all right here for you. Okay, you just got to go back to it after you find what x is. So this is just a revisit to collecting like terms, right? I'm going to add x's together, and then I'm going to add numbers together. Okay, I'm going to get something like, how many x's do I see there? I see 1, 2, and 3 x's, right? So I'm going to get 3 x's, and then plus 3. Is everybody happy with that? All right. So now you just solve for x. This looks like something that we've done before, right? So you can see how like what we're doing right now is 2 separate lessons. I need to teach you, or you need to develop the skills to be able to develop stuff like this, like above the line. And then you need to go back to the skills that I've shown you already in order to actually get yourself an answer. Okay, so 2 separate skills here, which is why we waited to the very end to do this. Okay, try to give you as much time and exposure to solving equations as we can. Sorry, I'll move that up so everyone see, okay? So now to solve for x. Well, take away 3, take away 3. We're going to get 3x is going to equal 108. Then I can divide both sides by 3. Divide by 3. Oh, sorry. I'm getting ahead of myself here. Silly me. 108 minus 3. That's 105. Okay. How many times does 3 go into 105? Or what is 105 divided by 3? Does anybody have that answer? Yes, Elizabeth? 35. Sounds right to me. Okay, so x is going to equal 35. So this marks, remember, this represents our first number. Okay, and then sometimes the equations are not always going to be as straightforward as they are right now, right? And in context here, we know, obviously because we've read the sentence or the statement, the other 2 numbers have to be 36 and 37, right? But they're not always going to be straightforward questions. And this is kind of what I'm getting, like the process here is nice. Whatever is going on with these questions, go back to the let statements that you developed at the very beginning. They're going to tell you what the answers are. Once you have what x is, to find the second number, take x and plug it into right? Plug it into x plus 1. So now we know 35 plus 1 equals 36. That's our second number. Okay, and then obviously you do the same thing for the last one. You plug it in, x plus 2, 35 plus 2. We get 37. Okay, you could, just to save time, we can put some therefore statements here. Okay? Does anybody have any questions with those ones? And hit stop there. Gwen, yeah?
Why couldn't you just do 3 times 36 to get your 108?
And then what?
Do you have to do anything else?
Well, it wants 3 consecutive integers, right? So you have to, you should have 3 answers. So it's not just 3 times 36. And there should be three numbers here because it's talking about 3 consecutive integers, okay? So again, there is definitely ways that I think in the elementary stage of these kind of word problems, there are definitely ways to do this in your head, but again, my job is to try to give you a process to fall back on so that you can tackle harder questions, right? Vincent, you okay?
I just took 108 and then divided it by 3 and figured out that would be the middle number in the sequence.
Yeah, again, process, okay? I can tell you from experience, and grade 10 math, you're going to have to deal with harder equations, and that's always the thing that stumps kids in grade 10. So you're not going to be able to do some of those questions in your head in grade 10, because you're going to have grade 10, you're going to have two variables going on now. It's not just going to be x anymore. Aaron?
Wait, so as long as you state the variables and what they are, then you don't have to explain your like equation?
You mean this part here?
Yeah, you don't have to explain where you got it from? Like,
I don't think so, really. I think this is like, this is a result of having to, sum three consecutive numbers. So I said in my let statements, I knew here's your first number plus your second number plus your third number. So my let statements, does that answer your question?
yeah,
Okay. So your let statements kind of like take care of like what's going on, and then you just choose in your head what do you have to do based on what you've read in the sentence. Is that all right? Okay.